Great, thanks, Tanya. Good morning, everyone. I'm Neely. I'm with Southeastern University. I'll be chatting with you today about in situ disease treatments for corals afflicted with stony coral tissue loss disease. Start off with all the people who make the magic happen, our funding sources, our permitting, and all of those who have assisted with this work over the past several years. Stony coral tissue loss disease is unprecedented in terms of the destruction that it can cause on Caribbean coral reefs. It started as a Florida problem in 2014, but is continuing to spread throughout the Caribbean. We know that it is characterized by extremely high mortality rates and on a very large number of species. And this has real ecosystem functions. We've seen declines in coral cover, species diversity, and reef function as well. Humans are very proactive about treating diseases in themselves, in their pets, and in agriculture. But the general rule of thumb for wildlife diseases is to let it run its course regardless of those consequences. However, there are important exceptions to that, and I've listed some of those here. In general, those occur when human or agricultural health is threatened, when ecosystem services that directly impact us are threatened, or when rare and highly managed species are at risks. And it is no stretch to say that SCTLD directly falls into those last two categories. So beginning in 2018, there was a collaborative effort to figure out if there was something that we could do to treat SCTLD in the field. And through those efforts, a topical amoxicillin paste was developed that's applied directly to afflicted corals. This paste has a 3-day time release, and it has polymers that allow the amoxicillin to go directly into coral tissues. Treatments are done on a coral by coral basis, but they are highly efficient. Most corals take less than a minute to treat, and the cost for materials to treat those corals is about $2 per coral. Numerous papers have come out about the efficacy of this treatment. We've treated about 26 different coral species and have enough data to confidently say that on all of those anecdotally and on most of those statistically, efficacy is about 90% in terms of stopping active lesions. We've had several thousand of these corals that we have tracked over multiple years. And through that, we've found that even though new lesions, so on some corals, new lesions will develop after treatment. And this is of consideration for those who might only be able to get to a site once or maybe twice. What would intervention look like for you in your region if you were going to do this? And what we found is that these differences are a little bit species specific. So between 20 and 60% of treated corals remain healthy for at least 1 year after treatment, usually much, much longer. With, again, those species-specific differences, with brain corals generally performing better. We've also found that of the corals that reinfect, most of that happens within the first 1 to 2 months after treatment. And so if you can get back and do a second round of treatment, you can increase those survival rates, and that most of these individuals will be fine for the following year. So what are some of the benefits of this? Well, we, again, have followed several thousand of these corals through multiple years. We have about 90% survival at that time frame. And because these are very targeted efforts, you can be very selective about which corals you're prioritizing and which sites you're prioritizing. So this is a way to really save the largest and oldest corals on the reef, and subsequently some of the largest and oldest coral animals on the planet. These are generally the ones that are providing those ecosystem services that are so important. These are the ones that are providing the reproductive capacity for the next generation. And these are the ones that have survived hundreds, if not thousands of years of stressors. It's also important to note that this is a way that we can save individuals for whom the classical restoration methods are really still in their infancy. This is really effective on a lot of different species. And just in terms of the efficiency, the fewer corals that we have to, the more tissue that we can save that's already on the reef, the more classical restoration efforts can focus on what's already been lost. And so we've calculated about the 4,000 corals that we've treated in the Florida Keys. That's equal to about 1 million outplants. And in high, what am I trying to say? Like on a research cruise where you're doing really high output, you could essentially equivalently outplant, what am I trying to say? You can essentially save the equivalent of 1 million coral outplants in just a few days. So with the efficacy of this, this has been scaled up throughout the Caribbean. We've got partners through the Caymans and Virgin Islands and other places have adopted this. This also gets adopted by a lot of our classical restoration folks. So this has been used in nurseries for corals that have been impacted by SCTLD, and for outplants where that effort has already been put into raising these corals, putting them out there, and this is a way of keeping them alive. So with that, I think I have a couple of minutes for questions. Thank you. Yeah. Thanks. Yeah. Those are great questions and definitely things that are actively under investigation. Reagan just gave a talk about some of the environmental factors they see up in Southeast Florida. We don't see a lot of those similarities in the Florida Keys. We definitely know that there are some differences in resilience, and again, Brian Walker's PIing a project that's taking those samples, sending them off to look at genetic components, zooxanthellae components, all of the omics. So there's a lot of differences that we're seeing, but we don't know what's driving those differences. It's a great question. Thanks. Anna. Yeah. For the $2? Yeah, so the major components in terms of the materials are the amoxicillin, which is pretty pricey, and the base itself. Everything else, when you're just talking about syringes and things like that, is pretty small. Um, that does not include staff time and things. And we've been working a lot thinking about what that looks like. And because it's so variable between regions, we're really not super comfortable talking about that. If you're shore-based, it's obviously way cheaper than if you have boats. A lot of our partners through the Caribbean use volunteers, which is quite different from paid staff time. So those costs can change quite a lot, but for everybody, it's gonna be that base materials cost. Yeah, yeah, yeah. Thanks, Anna. Okay, thanks everybody.